Hey guys, we're back with the notes for 10.4. We are going to be rewriting back and forth between exponential and logarithmic functions. So we learned that they're inverses of each other. They mean basically, they can be used interchangeably is what I mean. So I'm going to have you bust out 3 highlighters or 3 colored pens or something to help you identify the 3 main pieces because this system is our key to solving everything, okay? So log b of x is equal to y. What that means is that b to equal x must be raised to what power? And I know that that's kind of like blah, 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 but here's what this looks like when you're trying to solve it. The equal value in an exponent is what you are taking the log of. The equal in a log is what value the b must be raised to get your x. Here is how we rewrite these. It's called the swish or the loop-de-loop, okay? So if I ask you to take the log and convert it to an exponent, you basically say 3 to the power of 2 equals x, okay? That's the direction you go. Now, if I'm asking you to take an exponent problem and convert it to a log, you do that same circle, but it tells you to write it in order. So if I say 3x2, then I would say log base 3 of x equals 2. So that swoosh tells you the order when you go back and forth, okay? And we'll do a lot of these so you will see that example, okay? Here's my suggestion. I would bust out some highlighters, pause the screen, and highlight everything on this page, and then we'll go to the next one, okay? Perfect. Go to the next page. I would highlight everything in these 3 sections and then press play. Perfect. Okay, so I did the first one in each row just to kind of give you a base to talk about before we do a bunch of them. So in the first one, it says rewrite the log in exponential form, okay? So if I follow that swoosh every time, we're saying 2, let me erase the loop. 2 to the 4th power equals 16. You can kind of logically check to make sure that that makes sense, right? 2 to the 4th power, so 2 times 2 times 2 times 2 makes 16. Yes, we're good. Let's go to this one. 3 to the 0 equals 1. That makes sense. Anything raised to the 0 should equal 1. We're still good. 2 to the 2.585 equals 6. That's not one you're going to know, right? That's definitely not one that you're going to have memorized, but you could type it in a calculator and see if it comes out right. All right, last one, number 4. Notice there's no base on this one, right? No base. When we have no base in a calculator, we are going to assume that this is a 10. Okay, your calculator will default to log base 10. So this problem says 10 to the 1st power equals 10. Well, we know that to be true, right? Anything to the 1st power is just itself. Top row done. Second row, there is no equal sign. They're asking you to evaluate it. So they're asking you, what power would the base have to be raised to equal the blue number? Okay, so in this first problem, I'm saying log 5 of 25. What would that equal? Well, 5 to what power would get you to 25? We know that answer to be 2. 5 squared would equal 25. Let's go to this one. So I don't know what x is. I'm trying to solve it. So 5 to what power would equal 1? 5 to what power would equal 1? Well, we know to equal 1, you have to raise x as a 0. You have to raise it to the 0 power to make it come out as 1. Let's go to 7. If I say 4 to what power would make a 2? 4 to what power would make 2? Well, we would have to solve that using the rules that you learned in 10.3, right? So 2 squared to the x is equal to 2 to the 1st power. We would take our exponents then. We would say 2x would have to equal 1. Divide by 2, my x would have to be 1/2. So solving that problem, my value would be 1/2. Last rule, number 3, is if you take log base anything to a power, you will never get a negative number. Okay, you cannot take the log of a negative number. So when you get that, your answer will just be undefined. That would be there's an asymptote there, basically. Okay. All right, let's go ahead and go down to the next one. We've already done forward. Now we're going backwards in the same direction. So if I give it to you in an exponent, you are going to use that same loop-de-loop or that same swish to tell you the order. Okay, so follow my loop-de-loop. Let me kind of delete that. So I'm going to go in order 4 to 16 to 2. So my order 4 to 16 to 2. Log base 4 of 16 is equal to 2. I'm not asked to solve it. I'm just asked to write it out. Okay. So if I do this one, 27, 3, 1/3. Log base 27 of 3 is equal to 1/3. It tells me the order to write it in for the log. So 8, 4, 2/3. Log base 8 of, that came out weird. Log base 8 of 4 is equal to 2/3. And I'm going to write this one out just so you can hear me say this. This is how we say it. Log base 8 of 4 is 2/3. That's the language. That's how you read those problems, okay? All right, that is the end of that row. If you need to pause anything and write it down, we've done 1 through 11. Perfect. So the next step is very similar in the practice. We're going to do these 3 more rows, and then your assignment will be section 4, okay? All right, so problem 1 is still the same thing. We're writing it in expanded form. I suggest you pause the screen for just a second. Try ABC and then see if you get the same answers I do. So pause the screen now. All right, so if you checked and your A was already on the screen, so the next one would be log base 4 of 1 over 16, and most people would write that in parentheses, is equal to a negative 2. Last one, C, would be log base B of C is equal to Y. If that's what you got, then you're on the right track. Okay, why don't you pause the screen and try sections 2, ABC, try section 3, ABC, and let's compare at the end. Okay. All right, so if I'm having you check B, you should have 5 to the negative 1 equals 1 over 5. For C, you should have B to the V equals U. If you got B and C right, then you were probably on the right track. Last section for 3, you are solving for X. For A, if you got 4, that means you were on the right track. For this one, if you did 10 to the X equals 0.001, and again, that's tens, hundreds, thousandths. So I would rewrite that this way, equals 1,000th, okay? Then I would rewrite that 10 to the X equals 10 to the negative 3, and in this case, X would be negative 3. If you got that one right, bonus points, because that's a tricky one. And last one, we would say 8 to the what equals 1. I know that anything to become a 1 has to be raised to the 0. So I would make my X equal 0. Okay. If you've gotten all of those right, you are ready to start the practice. Your assignment is going to be section 4. I know they're not numbered, but it's A through R. Go ahead and get started.